first let's just kind of tack on what Rolle's theorem is real quick. This should be pretty easy, I hope, as far as Rolle's theorem goes. Rolle's theorem from yesterday was if I have a point A and I have a point B, and I've got some graph that's floating around in the middle, not really sure what it is. Some graph might look like this. At some point on that line right there, between this interval A and B, assuming these values are the same right here, I'm going to have a point somewhere on that graph such that the slope is 0. So I might be able to find this point right here such that that slope right there is 0. That's what Rolle's theorem said. Okay, now a couple little stipulations on this as far as Rolle's theorem. One, A and B had to be the same, right? They had to be the same height. And then the other part of that is this had to be continuous and it had to be differentiable across the entire region. Okay, if it wasn't differentiable, then I'm not guaranteed a slope of 0. Okay, so that's basically Rolle's theorem. You guys okay with that? Kind of. Okay. Now, real quick here, let me ask you this: what's the slope of this line right here? 0. Okay, that was the goal. That finding the slope is 0. Okay, what's the slope from A to B? If they're the same height, 0. Notice they're the same. Okay, for Rolle's theorem, that's always going to work, right? If I have the two f of a and f of b, they have to be at the same level somewhere. The graph can do whatever. Some point on that graph, if it's continuous and differentiable, I should have a line that's parallel to that slope of 0. I should have the slope of 0. Okay? The mean value theorem says this. Literally, we just turn it sideways. So now A and B don't have to be at the same level. I can tilt those a little bit. Okay? If I tilt this and I have this secant line, some slope right here, that slope might be something else. I have a slope somewhere on that graph that's going to be the exact same slope as that. It's going to be parallel to that. Okay? So it's slightly different than Rolle's theorem. It's just turned on its side a little bit. Okay? Rolle's theorem says this. Mean value theorem says this. If I have, once again, I'm on this A to B idea. So I'm going to start here at A. And then up here is where my B is going to be, somewhere up there. Not really sure exactly where it is. But I know if I have continuous, it's got to be continuous differentiable. Okay, all that's still the same. But if I've got some graph that's going to go something like this and something like this, right? And the graph can be pretty much whatever. It doesn't matter. Okay? If I think about what the slope is from A to B, okay, the slope would be like this secant line right here. Okay, the secant line goes through those 2 points right there. So somewhere on that graph, I'm going to have a slope that's going to be exactly parallel to that line right there. Okay, I'm guaranteed that if it's differentiable and it's continuous across the entire region. So I'm looking for this point right here. I'm looking for those such C values, same as before. I'm looking for the C values such that this line right here is going to be parallel to this line right here. Okay? So what I'm looking for is this line right here is going to be my f prime of C. Okay? I'm looking for a C value, and I'm looking for the slope of that C value. Okay? I want the slope right there to equal, I want that to equal the slope of this guy. Okay? Now the slope of this line right here, we're just going to do like a rise over run type idea. But the slope of this guy should look like this. It should be f of b minus f of a over b minus a. Okay, now slope or derivative or all that fun stuff, they call this the average velocity, right? We're taking the average velocity over a given period, over a given interval. And average, mathematically, that's what the mean stands for. So that's kind of the idea behind what we're doing. Is we're taking the average over a to b. And there's somewhere on that graph that average will match, that average will be the same. Okay? So our goal for this, it looks a little funny, it looks a little messy, but our goal of this is to find the C values, such as the slope at that C value equals the slope of our endpoint intervals. Okay? Kind of make sense a little bit? Now the wording of all the directions are going to be super weird and kind of gross to get through and drudge through, just by how they're going to ask you the questions. But in a nutshell, that's what they're asking you. Find the C values, such as the slope of this line right here equals the slope of your endpoints. Okay, the slope between your endpoints. That's really what we're trying to get at. Okay, so that's what the mean value theorem says. Once again, this has to be continuous and it has to be differentiable. Okay, so like number 15 that we did, right? Even if this were tilted a little bit, we couldn't apply it because it's not differentiable across the entire region. Okay, so this still has to be continuous and differentiable.
And differentiable just means taking the derivative.
Taking the derivative, that's all it means. Yep, taking the derivative. And they get a little bit funny as far as the notation that they go on. They talk about like the mean value theorem over the interval a to b, and usually they do like a square bracket interval a to b like so. And then they'll say find the C values, just so you're not too confused. Find the C values on, and then they'll go a to b, like that. And they won't put the square brackets right there, because they don't want an endpoint to actually count as one of the points. And the reason is it has to be differentiable across the entire region. We can't differentiate an endpoint. right? We can't come at the limit from both sides, okay? Remember, that's kind of our main definition of a derivative, right? It's that whole big limit process. We got to come at it from both sides. I can't come at an endpoint from both sides, so I don't know what the slope exactly is right at the endpoint. So that's why they'll change from a square bracket right here to an open interval right here, because the c value has to lie between the open interval, i.e. I can come at it from both sides, okay? Does that make sense? Kind of. I know that was a little bit of theory there, but basically, if I'm on this point right here, right close to A, I can come at it from both sides and find the slope. Okay, right at the end point. Okay, cool. So that's mean value theorem. Let's go ahead and take a couple look at a couple problems, and my dyslexia is kicking in this morning. Okay, so let's say we have f of x equals 5 minus 4 over x, and then I'll say my interval is from 1 to 4. And the directions are going to be kind of weird and kind of gross and kind of ugly. Find the c values such that I love such that for some reason. Such that the derivative at that c value equals the slope of my endpoints. Okay, the slope of the endpoints is going to be f of b minus f of a over b minus a. And just to help clear things up a little bit, this would be A and this would be B. Okay, so maybe that helps a little bit. But basically what I'm doing is I'm finding the slope between these 2 points, and I want to find somewhere on that graph that the slope equals, that wherever that specific value, the slope equals the endpoint slopes. Okay? So let's go ahead and try to figure this out. First thing I like to do is I like to find this real quick. I like to find the endpoint slopes first, okay? Because that's usually pretty easy, okay? So what I would do is I would find f of b, f of a, and then divide that by b minus a. So let's figure out what our slope actually is and what I'm trying to match up to, okay? So I'm going to do f of b. So plug in the b value, plug in a 4 right there. So 4 is 1, 5 minus 1 is 4, I believe, right? So this should be 4. And I'm plugging in, let's see, f of a now. So I'm going to plug in a 1. Okay, so 4 over 1 is 4. 5 minus 4 is 1. So I should get 4 minus 1. Okay, I'll divide that by the interval gap there, or b minus a. So b is 4, a is 1. So 4 minus 1 here. And we get 1. Okay, so the slope between these 2 points right here is going to be a 1. Does that make sense? We're okay so far? Now, feel free to graph this, and just to get a ballpark, to start learning about these things, there's nothing wrong with going to your graph. Okay, so our graph, our slope is 1. Now what we're searching for is the derivative equals 1. Okay, we're no longer setting it equal to 0 or setting it equal to find those critical points. I want to find out the c value such that the slope of this guy, the derivative of this guy, equals 1 now. Okay, so I'm going to take the derivative of that function. Let's go ahead and find the f of x. So we'll take the derivative of this guy. Derivative of 5 goes away, and then derivative of negative 4 over x. Amy?
Yep.
Is that f of x or f of x?
That's f prime of x. Thank you. Okay, what I would probably do is make this 5 minus 4 over x. I would make this 5 minus 4 to the x to the negative 1, or times x to the negative 1. So 5 minus 4x to the negative 1. And then derivative, that's going to give me 0. And then here it's going to give me a positive 4. And then x to the negative 2. And then move the x to the negative 2 to the bottom. So my derivative should be 4 over x squared. Okay, so that's my derivative. Looks pretty good. Now what I want to try to do is I want to try to find out the c values of my derivative. That's this equation right here. I want to find out where that guy is going to equal 1 now. Somewhere on that graph, I'm looking for where that guy equals a slope of 1. Those are the c values that I'm trying to find here. Okay. So we need to solve for x here. Okay. So what are my x values for this one? 2 and negative 2, right? Plus or minus 2 if I were to be doing that, right? So technically x here would equal plus or minus 2. So I have 2 possible values for this graph right here, which my slope is going to equal 1. Okay, well, there's kind of a small problem with this, right? I got plus or minus 2. I can't actually use both of those. Why not? One's out of the interval, right? So we're not going to use the negative 2 here. We'll only use the positive 2 because that's the only one inside that closed interval from 1 to 4. Yep.
Where'd you get the plus and negative 2?
Because if I plug in a plus or negative 2 here, 4 over that squared is going to give me 1. If I were to try to solve that, I would multiply by x squared on both sides and then square root both sides and be here. Okay. So I get x is plus or minus 2, but I'm going to scratch that, and I'm going to say x equals a positive 2, and that's because of my interval. Okay, it's got to be the interval between 1 and 4. Okay, so that means on this particular graph right here, this particular graph, from 1 to 4, right, I've got a slope between 1 and 4 that when c value is 2 right here, my slope will be exactly the same. Okay? Now, as far as checking your answers go, let's go ahead and see if we can't just graph this and get a graphing visual of what the heck is going on here. Okay? So first off, let's just graph our main function, which is 5 minus 4 over x. Looks like that. I should probably put this under here so people can see. Thank you. You're welcome. And then, okay, so let's zoom 6, see what it looks like. Looks like that. Cool. So there's our graph. Now, speaking of not being continuous, this isn't continuous at 0, right? Everybody's okay with that? Right, and that would make sense if you looked at the derivative. If you plug the 0 in for the derivative, it's undefined. So not differentiable across the entire region, okay? So there's my little graph right here. I'm going from the interval from 1 to 4, okay? So if I were to just do a little calc value, x equals 1, that's that point right there, okay? So I kind of want to draw on the TV if that's okay with everybody. That'd be this point right here. Okay, and then the other point would be 4, so let's go ahead and plug in a 4, so that's going to be 4, 4. That's this point right here. Okay, so this is my secant line right here. Going right here. Now what I'm looking for is I'm looking for a point. I can kind of ballpark it and guess it's going to be somewhere in here, right, ballpark, just because that looks like that's where it's kind of the tangent line is going to be, okay? So what you can do on this one is you can just go to test our value. What was our value? 2. So we got a 2, and that's about ballpark if I were to try to visualize a tangent line on that guy right there. Okay. Now, a couple things we can do, if you want. This is a bit overkill, just a little bit. Let's go ahead and put both of those lines in our equation now. That's going to be a little bit of work, right? Okay, let's go ahead and find the equation of the tangent line right there at that point. Okay, we've done a bunch of that before, right? And we'll write an equation for a line. It's y equals mx plus b. I know what the slope is, right? What's the slope right at that point? 1. So I've got y equals 1x plus b. Now I've got to find out what the y-intercept is. So I need a point, right? Well, I know my x value. My x value that I found was 2, right? 2 is the x value. And what was the value at 2? It was 3, right? So that means I'm going to get 3 equals 2 plus b. So I'd subtract, so I get 1 equals b. So my equation is y equals x plus 1. Okay? So if I go to my graph now, go ahead and graph y equals. And then down on the second graph, just graph y equals x plus 1, and graph. And that should go right to that point at 2, which they're going to intersect right at that point. And you can use a little intersect feature if you really want to. And then notice that it's parallel to the other line. Okay. Now, you could also graph the other line as well. Okay, I just did y equals mx plus b here, right? We could graph that other line as well. We just need another line, right? So let's go ahead and try to find that other line real quick. Once again, I would use y equals mx plus b. And now I'm actually trying to graph, now I'm trying to graph this secant line, which is right here, right? Well, we know what the slope is there, too, right? What's the slope of the secant line? 1. Okay, so y equals 1x plus b. So I got to find my intercept now. So now I need a point, okay? Well, I need a point that goes through those secant points, right? Okay, 1. What was the value at 1? When x was 1? It was 1, right? It was 1, 1. 1, 1 was our point. So 1 equals 1 plus b. Move the 1 over, that means b equals 0. So then I have y equals 1x. So y equals x should be my original secant line. So if I go back to my y equals, type in an x, and hit graph, that'll be that secant line right there. Notice they're parallel. It goes through my 2 points, and I found that c value that works. Now, ultimately at the very end, what they're asking you for is finding c values that make the slope the same, right? So really all they're looking for is this value right, I erased it. X equals 2. That's what they're looking for. That's the c value that matches the slope.
Could you use the 0.44 as well?
Oh, yes, sure could. Yep, because if you plugged in a 4, 4 here, you'd still get the same b value, right? So you can totally use either point. Doesn't matter. Okay. All right, cool. So feeling semi-okay about that? Should we do one that's a little tougher? Slight bit? They're not going to get too much tougher. I mean, the only way they make these a little tougher is the derivatives get a little harder. What they do. You know, we can dominate those. I'm not worried about that. All right, one real quick, and then we'll be good. Okay. Okay, so once again, directions are kind of funny, but they're going to say find the c-values so that this works. Basically, the slope between the two endpoints, we want to find the c-value on the graph somewhere such that the slope equals this guy right here. And feel free to use your calculator on a lot of this stuff, but we got b minus a, so 1 minus the negative 1 for the denominator. Plug in a b, which is 1, right? So let's go ahead and second calculate value. 1 is negative 2. Minus, plug in a 1, no, sorry, plug in a negative 1, 0. So my slope for this one's going to be a negative 1. And that's between my endpoints, negative 1. If you'd like, you can just write an equation of that line right away, just so you have kind of a visual of what's going on. We have y equals negative 1x plus b. Remember, my slope is negative 1. Find the b value, so just plug in one of the points. I'm going to plug in, let's see, was it 1, 0? Was that a point? No, it was negative 1, 0, okay? So y was 0, and then that equals negative 1 times negative 1 is 1 plus b. So b would equal negative 1. So my line right here would be negative 1x minus 1. I believe, and that'll be the line between my two endpoints. Okay, so I'm going to just throw that on the graph real quick here. So I got this here, negative x minus 1, and graph. Looks pretty good. It's kind of tight, so I might zoom in just a little bit here. Oops. Break my calculator. Okay, so it looks something like that. So these were my two endpoints right here, right? Now I want to find some point along this curve right here, some point along that curve that matches the slope of this. That's what I'm looking for. Okay? So it's Rolle's theorem basically turned on its side. So let's go ahead and find that c value. So we're going to do that by taking the derivative and then setting the derivative equal to our slope, which was negative 1. So let's go ahead and take the derivative of this guy, which is going to be, what, 3x squared, and then minus 2x, and then minus 2. That'd be our derivative. Okay, I want to find out the c value such that my derivative, oh, did I screw it up?
Did you just do the product rule all in your head or something?
No, I distributed the x and then just power ruled it. Because this would be x cubed, so 3x squared, and this would be negative x squared, so negative 2x, and then negative 2x, so negative 2.
You sound more impressive.
Yeah, I did the product rule. Yes, I did. Wouldn't be too bad, because that'd be 1, so it'd be this guy plus. Okay, maybe not. Okay, so set this equal to my slope. Okay, set this equal to the slope, which was negative 1. So now I want to solve this equation. For x, find my c values. These are the c values that I'm searching for, such that the slope equals negative 1. So different kinds of x's probably want to factor, so maybe move this 1 to the other side, make it equal 0. So 3x squared, let's see, minus 2x, you got to add 1, so minus 1 equals 0.
Why do you have a negative 2 for the derivative? Shouldn't that just be 0?
No, okay, sorry. Distribute this x in there, x cubed minus 2x minus, I'm sorry, minus x squared minus 2x, and then I power ruled that. So now I'm going to solve this, which I think this one's factorable. 3, yeah, I think I can factor this one now. Equals 0, so this would be a 3x and an x, and a 1 and a 1. And I want a negative 2x, so I probably need a negative here and a positive here, I believe. It's pretty good. And then, so that means my values here would be a negative 1/3 and a positive 1. Okay, so negative 1/3 and a positive 1, those are going to be my, my points that I'm looking for. Okay, so those are my c values. Now there's a slight problem with that, with getting both of those answers. Which one of those answers is not going to work? One's not going to work. Okay, 1 is the endpoint. We don't want to use an endpoint. Remember, we're looking for the points that are on the open interval, negative 1 to 1. Okay, so it's got to be differentiable, and it's not differentiable right at the endpoint. Okay, because well, we're assuming the right side of the graph isn't there. So, all right, cool. So we get so this answer I'm going to cross out. I'm not going to use that one. I'm only going to use x as negative 1/3. Okay. So if I were to, let's say I were to draw the equation of this line, I would maybe double check just to make sure that it looks right, but let's go second calculate value, negative 1 divided by 3. I get that point right there. That looks, reasonable. Looks like my slope right there is going to be about parallel. Let's just double check it just to make sure I'm feeling pretty good about it. Write the equation of that line. I've got y equals the slope, mx plus b, right? The slope is -1 still, right? -1x plus b. And now I've got to find out what the b is, which means I need a point to plug in there. Well, I just found an x value, -1/3, right? So I've got -1 times a -1/3 plus b. I need the y value for that, right? What's the y value? 0.518518,518,518. I wonder what that is. Let me just check. 0.518518,518. Ha, 14/27. Cool. So 14/27 is the y value there. 14/27. I know I cheated a little bit. And this is going to be a positive 1/3. So I would subtract 1/3 on both sides. I'm going to take away a 1 divided by 3, and I get that, which let's go ahead and make that a nice number. And I get 5/27. Okay? So 5/27 is my b value. So that means my equation for this guy is y equals -1x. I guess -x, I could say. And then plus 5/27. Okay? Throw that in your y equals. Make sure it looks right. Okay? So let's go back to our y equals. I'm going to go down to my third equation here, -x plus 5 divided by 27. And let's go ahead and hit graph over. Right, pretty good. Okay? We only have you just second calculate value and then -1/3. And yeah, looks like that's a good intersection point. So, you feel pretty good about this? Kind of? Not too bad? I hope. All right, cool. 177.